Hey there, I'm Ken. This is Canadian Retro Things. Welcome. Something I haven't talked about before is that I like calculators and adding machines. So today, I'm going to take a look at one from my collection. What I'm going to be looking at is what I would consider to be an interesting desktop calculator. It's the Commodore US-8. How closely am I going to be looking at it? Well, of course, I'm going to be taking it apart, but I'm also going to be looking at the functionality of it, and I'm going to show how it differs from a regular calculator that you probably know, like, for instance, the one you have on your smartphone. But before I do any of that, I want to give a big thank you to the sponsor of today's video, PCBWay. Do you have an idea for the next big gadget to add to your retro computer? Why not check out PCBWay, where they can print your circuit board for you starting for as little as $5 for 10 boards. And if this is your first order, you'll get a welcome bonus of $5. This means you can try out PCBWay for the price of having your project boards shipped. So, if you want to make that idea a reality, PCBWay can help you. Why do I think this desktop calculator is particularly interesting? Well, aside from the fact that it's the same age as me, this was also one of the first desktop calculators that Commodore made. Now, I hear you shouting at the screen that Commodore had plenty of desktop calculators before this one, and, well, you're right. But this was one of the first ones that they made. The previous ones were made by different companies, such as Casio, and sold to Commodore for them to put their name on. As you can see, on the calculator part, there are the 0 through 9 keys, as well as a decimal key. And to the right of the number pad, there is the 4 function keys, a multiplication, division, minus equals, and plus equals. Directly above those keys is a 4-position switch. Now, it's a little difficult to read exactly what it says above and below this switch, but it says decimal set below it, and above it, it has F, 2, 3, and 4, which stands for floating decimal, or 2, 3, or 4 fixed decimal places. On the left side, there are 3 keys. C in the middle stands for clear. It zeroes out the memory. Just below that is the CE key, which stands for clear entry. You use this key to erase anything that you've typed in, but not hit one of the operator buttons yet. At the top is the K key. The K key is unusual for one of these, but I believe it's known as the constant all 4 function key, but I'm not entirely sure what it does. So if you know, then I'd love to hear about that in the comments. It is a locking key. It's the only one of the keys that actually locks in the down position or the up position. At the very top of the calculator here, right beside the Commodore symbol, there is the power switch. And because I'm showing you the power switch, you obviously know it is time to turn it on. Takes a second to warm up, and there you go. You'll first notice that it has a beautiful 7-segment gas discharge display panel with 9 positions, as well as decimal points between each segment. Now, only the first 8 actually will give you numbers. The 9th one is for either the error symbol or the negative symbol. The screen also has 8 numerical positions numbered as part of the screen mold. It might be a little hard to see here, but there they are, just 1, 2, 3, 4, 5, 6, 7, 8. And now I'll give you a quick lesson on how this type of calculator differs from the type of calculator that most people know. The difference is mostly in the plus and minus functions. The multiply and division work the same, but you have to use the positive equals key. If you don't, let's say 10 divided by 5 equals 2. But if I go 10 divided by 5 and I use the negative equals key, it gives me a negative answer. So you always got to make sure that you use the positive equals key for the plus or the multiply and divide. When you're adding and subtracting numbers, that's when it gets a little different than a regular calculator. Not so much in the adding, because let's say you have 2 plus 3 equals 5, you get the right answer. Subtracting is when it gets awfully different and you have to change your mindset. Let's say you have 15 minus 5, and that should equal 10. Well, what happens if we type that in? 15 minus 5. Well, which equal sign do we use? Well, let's use the positive one. Negative 10 is not the right answer. Well, maybe we should have used the negative one. Well, minus 20 is further away from the right answer. So what you have to do when you are adding and subtracting numbers is break them down into the individual numbers. So you look at it as the 15 is a positive number. The 5 is a negative number. There you go. That gives you the right answer. So what you have to do is break your numbers down into individual numbers and enter them as positive and negative numbers. Just a list of positive and negative numbers. This seems a little silly when you're doing it for like 2 numbers, but if you're adding and subtracting a column of 10 or even 100 different numbers, it's very fast. Although it is sometimes a little confusing to jump back and forth between adding machines and calculators. Well, I could talk about the operations of adding machines versus calculators for hours, but I'm not going to bore you with that because I know you are here to see what this looks like on the inside. So it appears that this should be 3 screws here, although I was looking and this one seems to be missing this screw. I guess that definitely means somebody's been inside this before, but we'll take out what we can and ooh, longer screw in the back. Now there is a little flathead screw right here, but not sure that is part of taking this thing apart or not. Seems to be held there, so maybe that little flathead screw right there is one that has to be taken out. Let me just find a little flathead screwdriver. Huh. Seems like that is almost a... Oh yeah, that did it. That's a plastic screw. I don't know if that is original, but that is pretty darn interesting. That there is a completely plastic screw in there. Comparatively to the screw that was beside it, it's a little bit bigger, but completely made of plastic. Anyway, enough about the plastic screw. Oh, looks like it's all attached to the top of it. There we go. There is the circuit board. It's got a fuse up here. And that'll be the power pack. And a couple more screws here to take apart. Ah, interesting. So, gonna have to do it like this because it's still attached to the power source back there, and I do not want to unsolder that. So let's get that nicely centered here. There is really not a lot to the interior of this calculator. So here you can see your sliding switch. There is the brains of the operation, your display screen, some capacitors that all look fine to me. Nothing is leaking. Some little resistors. Right here is the brains of the calculator. It is a Texas Instruments TMS-0103 chip. Now, looking it up online, it turns out that this is a member of the Texas Instruments TMS-0102 family. The TMS-0102 was originally introduced in 1971 and was a chip containing 3,520-bit read-only program memory, a 182-bit random access memory, and a decimal arithmetic logic unit, as well as control, timing, and output decoders. All of this gives the chip the overall complexity of roughly 5,000 transistors. Now, for those of you that are particularly interested in this chip, or just particularly interested in chips in general, here is the pinout description of this chip on the screen right now. And before I put all of this back together, I guess we can take a bit of a closer look at everything that's in here. And above the screen you've got capacitors, some resistors. Over here it looks like a voltage regulator, some more resistors. Then you've got, of course, the display screen. Just below the screen we've, of course, got the brains. A whole bunch more voltage regulators, obviously going into the screen there. Some more resistors and capacitors. Now, when we look at the back of the board, it's all just the trace lines here. There's a couple of spots where things are labeled. Right here it says negative 15 volts. That one says 0 volts. One of the things I really like about these older boards is the way that all of the circuits are almost look like they're hand-drawn, the way they just flow around everything. Modern boards have those straight right angle lines. Everything's 90 degrees or 45 degrees, just straight, boom, boom. These ones just nicely flow around everything that they're supposed to. It's almost a work of art in itself. Okay, well, I guess it is time to put this thing back together and make sure I didn't break it. It's funny, no matter how many times I take something like these electronic things apart, I always expect I'm going to break them when I put them back together. I think it stems from the fact that when I was a kid, before I really knew what I was doing, I took a lot of these things apart, but could never figure out how to put them back together. And it still works. Seems to be working fine. See, no worries. I wasn't worried. Were you worried? Well, there we go. That is a look at my Commodore US-8 desktop calculator. It's amazing that that thing is the same age as me, and, well, I would say it's in better shape than I am. So I hope you enjoyed this look at that particular desktop calculator. If you did, you know what you can do with the liking, the subscribing, and the commenting below. Because anything and everything you do is always greatly appreciated. But I'm here in the woods. It's berry season, so I think it is time for me to pick some berries.